All right, let's look at the final exam review. Problem number 11. It says a cylinder contains some number of moles of an ideal gas. The cylinder has a movable piston on top, which is free to slide up and down, and which keeps the gas pressure constant. Okay, so that's a big key to this problem. Pressure is constant. It's the same always. The piston's mass is 8,000 grams, and its circular area, cross-sectional area, is 5 square centimeters. So first let's find the work done on the gas as the temperature is raised from 30 degrees to 275 degrees Celsius. Now you'll have different numbers in here, so I'll just do the general case. So recall that work done by a gas equals minus pressure times change in volume. And that minus sign is important because it means that if the gas expands and delta V is positive, then the work done on the gas is negative. In other words, the gas loses energy if it expands and pushes something like a piston. And that's going to be the case in this problem. So we can rewrite this as minus P times V final minus V initial. And now there's two ways you can approach this problem. One way is to use this information about the mass and the area to directly calculate what this pressure is. So you can say that the force is mg, force divided by area is pressure, and you would have a value for this pressure, and then you could calculate V final and V initial using the ideal gas law. That's one way to do this problem. That probably takes longer than the way I'm going to show you. The way I would recommend doing it is to write down the ideal gas law. PV equals nRT, and note that V equals nRT over P. And in this problem, because N is constant and P is constant, we can just say V final equals nRT final over P, and V initial equals nRT initial over P, and then substitute those into our expression for the work. So this equation becomes minus P times nRT final over P minus nRT initial over P. And notice those P's all cancel out. So we don't have to find the pressure at all. And we get this result that the work is minus N R times T final minus T initial. And you can plug in your particular values that you're given in this. Note that the final temperature is higher than the initial temperature, so this delta T is positive, and there's a negative sign here, which means that the work done on the gas is negative. Again, that makes sense because you're heating up the gas it expands, it pushes the piston, so the gas is doing work on the piston. It's doing work on the surroundings. Therefore, the work done on the gas is negative. So this part B question would be the type of thing where on an exam I would say I wouldn't have it multiple choice like it is here. I would write this as an explanation thing. I would say, please explain what that minus sign means. And you could say that minus sign means the gas is doing work on its surroundings. It's losing internal energy as it does this work. Okay, that's problem 11.